Equivalent means the same. So this is an example of equivalent. 2 equals 2. These are also equivalent. 2 equals 2 plus 2, take 2. But equivalent fractions are things like if you played half a game of netball, that's the same as playing 2 out of 4 quarters. Both of them would be considered a half a game, or those two fractions would be equivalent to each other. So today what we're going to focus on is what it means for two fractions to be equivalent or the same. And down the track, what we're going to be looking at is how we can actually write fractions in what we call the simplest form by dividing through by the HCF, or the highest common factor. Right, let's get stuck into the lesson. So the first thing we'll do is do one of these smart quizzes. And what it does is it looks at how to compare fractions. One thing that's of interest here is we're looking for this misconception of if we were to put an operation between these, so if it's a greater than or a less than symbol, which one would go between these two numbers? Okay. Now, some students will say that 1/5 is larger than 1/4. They'll say that, and the reason they say that is because they look at 5 and they look at 4 and they say 5 is more than 4 from what I know, which is completely true. Therefore, this fraction here must be bigger than this fraction here, but couldn't be further from the truth. 1/5 is less than 1/4. And again, if we think about this in context, let's grab a cake here. And if you imagine the cake was divided into quarters or divided into fifths, this is going to be a bit harder. So we're going to try and put it into fifths. How am I going to do that? I should have chosen an easier one. Let's change that to sixths, 1/6. And what we would do to put it into sixths is that's going to go into eighths, isn't it? There we go, I finally got it. So there's sixths, okay? And 1/6 is smaller than 1/4 because if you consider this is a quarter of a cake and this is 1/6 of the same cake, okay? Well, if you liked cake, which one would you take? You would take this one here because it's more than this one here. So we need to do more than just look at that denominator to say which one is the bigger fraction. We need to think about what each of those might represent. So that's what the smart quiz is going to attempt to pick up, is any misconception about that bigger denominator. Right, the second activity that we'll do today is we'll look at this picture here, and what we want to find is what's the same about the two shapes when we select a pair of shapes and what's different about the two shapes. Okay, so you might, for example, take J and K, this one and this one. So what's the same? Well, it's what it represents. So J and K is the same size. What we have, or what it represents though, is different proportions. If blue, say, is what we have, or if the white part is what we have is different. So different is what we have. So this one might represent 1/5 of all of it. This one here looks like it represents a fifth plus a little bit more than that, maybe 2/5 or even a half if I move that bit over to there. Okay, so different is what we have, 1/5 compared to half. Let's look at another example. C and D. Again, exactly the same situation. Same size, okay, so we've got the same size, so this is like the same size cake. What's different is what we have. In this case here, we've got maybe what looks to be a sixth or so compared to all of it. All right, let's have a look at another one. So we're going to do G and A. All right, what's the same about them? Well, it's not the same size this time. It's the same fraction that we have. So in this case here, we've got a half, and in this case here, the G case, we've got also a half, okay? What's different? The whole, okay? What it actually represents. So if I said to you, oh, I drank half a drink last night, the next thing you might ask me is, well, how big was the drink? If I said it was a 4-litre bottle of Coke, you'd be like, oh, that's a lot of Coke. But if I said, if I drank half a drink and the drink size was 200 mils, you go, oh, only 100 mils. You mustn't have been very thirsty, okay? So what it actually represents, that half and what it actually is the interesting part, okay? And if I just say I drank half a drink last night, invariably the next question will be, well, what was the whole? How much did half represent in terms of or in proportion to the whole? Okay, after you've done that, we've got this magic square problem here with a number of clues down here, so you can do that. And activity 4 is about putting these sets of fractions in ascending order, which means smallest to largest. And what I want you to do is try doing this without if you know how to do this, that's great, but common denominator. Okay, so what I want you to do is attempt to do this without a common denominator. Okay, so some students, what they'll do is make the same amount of parts or use equivalent fractions to do this. But what I want you to do is just think about these fractions. Now, I'm going to do the first one for this video here, so pause it if you want to have a go. If you have done it and are looking for a bit more information on how to do it, here's the method. This is 5 parts out of 13. This is 5 parts out of 12. This is 5 parts out of 11, okay? These are fractions of an amount, okay? And if it's of the same amount, what would be the biggest? Well, it would be 5 parts out of the 11 parts. This would be the biggest fraction. So this one here would be third. That's absolutely the largest. Then if I had 5 parts out of 12, there's more parts and I've got 5 of them. So the part size has got a little bit smaller. Here we had 11 parts, here we've got 12 parts. So this one here would be second. This one here is obviously first or the smallest. So again, thinking about a cake, if I cut the cake into 11 parts and took 5, that would be the bigger proportion than if I cut the cake into 12 parts and took 5, or cut the cake into 13 parts and took 5. Right, not too bad with that one there. Gets a little bit tougher with different denominators. Okay, so as they vary the denominators and vary the numerators, what you've got to try and do is pick the biggest fraction. Feel free to test your answer out with the calculator or by finding a common denominator to see how you went. Right, the last one we'll do as a class is this activity, the famous quarter the cross. Okay. So what you need to do is colour 1/4 of this cross, and you need to be sure, like absolutely positive, that it's a quarter, okay? So you can't be like, oh, it's probably about a quarter, okay? So here's a really simple method or an uncreative method. So what I'm going to do is note that there's 1, 2, 3, 4, 5. There's 5 parts on this cross. All right, so how do I actually colour in a quarter? Well, what I'm going to do is cut the shape up. So what I'm going to do is divide this part here into 4 parts, 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 this part here into 4 parts. All right, and now what we're going to do is colour in 1/4 of this cross. All right, so let's choose a cool colour. All right, and what I'm going to do is colour in 1/4 of this. Now what I'm going to do is colour in 1/4 of this part. Quarter of this, quarter of this, and a quarter of this. Okay, and what has actually ended up happening is because I've coloured or divided each part of this into a quarter, these quarters here represent exactly 1/4. Now, how do I know? 1, 2, 3, 4, 5. I've coloured in 5 parts out of 4, 8, 12, 16, 20. I've coloured in 5 parts out of 20. And again, maybe from primary school, you know that if I divide by 5 and divide by 5, that is the same as 5 divided by 5 is 1, and 5 goes into 20 4 times. 5 out of 20 represents 1/4, okay? And you can get a little bit more creative with it, so colour in the rest of it. Feel free to do that a different colour. So yellow there for argument's sake. So this is a fairly uncreative one. And what you can do, you can get as creative as you like on that one. So many students in my class last year further divided up these parts into more parts and then coloured in that to make a nice little kind of checkerboard pattern, I suppose. But there's many creative ways that you can do this. So try and vary the shapes that you use. Instead of using squares, use rectangles, etc., etc. There's 6 in the template. That's them there. It's not a Sacre-Cœur activity. I pinched this one a few years ago, and many schools do this and post the results. So if you Google quarter the cross, what I'm expecting you'll find is a number of different examples. So if you're looking for some inspiration, go have a look at one on the internet or 2 on the internet and see if you can get some ideas from there.